Hello, hi everyone. Hi Tuana, how are you?
Hi, I'm good. How are you doing?
I'm great. We're gonna wait for some people to join us, and meanwhile, just let us know where you're tuning in from. Um, we're gonna get some time for people to join the live stream, and then we can start. Um, I'm Pavel Dukovny. I'm from MongoDB. I'm a lead developer advocate here at MongoDB. And yeah, I see people from Texas.
Nice.
Hello. I'll be hosting you today, and we're going to be live coding, which is always relaxing and, fun.
Huh. Let's see how it goes.
That will go great. Um, yeah, we're going to be joining after probably a busy day at work. So
Yeah.
our jokes and conversation can, make you feel better towards the evening time.
Lovely recipes, hopefully, make you feel better. Sinan, I actually went to high school with Sinan. Hi.
Hey, cool.
Nice to see you here as well. Now I really hope we don't get anything wrong.
Hey, from Argentina. Wow, far away. Well, far depending where you're based out of, obviously. Hello
We
from
have quite a mix of time zones here.
yes. So we really wish that people keep it interactive. If you have questions, if you want to interrupt us, if you want to let us know your thoughts or questions, obviously place them in the comments. Uh, we'd be more than happy to answer them. If we'll not be able to answer them live, we'll probably do that later uh, on the different threads or even on our community forums that I'll let you know where they're at the end of the stream. So,
Yeah, I'll
hello.
definitely answer questions later on in the thread if I can't answer any live. If there are some questions I don't answer live, I'll get back to the thread after the live stream for sure.
Yeah, we're gonna start in 1 minute, but Joanna, you remember where when I met you? That was like a few months ago.
It was a few months ago, and I was not here. I was in the US, I think. I met you in Richmond I think it was on a call that we did about
All that
collaborating.
they did. And you met Richmond at an event, or you also
I think so. I think we both think we actually met at an event in the UK, but we weren't entirely sure. But I think we've met each other in person. I think all of the hackathons and events kind of blur into one at some point, but we're pretty sure we've met each other at one of them.
yeah, great. So I'm Pavel. I'm lead developer advocate at MongoDB, and Richmond is also a staff developer at MongoDB, and we're both on the AI ML pod, which means that we get to join forces with lots of great companies. And Tuana from Haystack is here today because we've been working on some initiatives together, and it's really exciting. Um, so I'll let Chuana first introduce us to Haystack and explain what Haystack is and how it integrates with MongoDB and MongoDB Atlas. And then we're going to build some cool stuff within minutes, hopefully, right?
Hopefully, yeah. And it's going to definitely be stuff that you can take over and make even better and extend on for sure. So I think what we show here today is basically just the start of it. You can really take it to any extent you like. But hopefully, we'll be providing the code after as well. I think it's already
Yeah.
public. So you guys will have everything you need to run the examples, make them even better than we have right now. I would be
Yeah.
very interested to see that.
Yeah, we always like when our project gets enhanced and suddenly you see, wow, I haven't thought about it. That's really cool. Like, and I hope I spark this idea in somebody's mind and they get creative with it. It always satisfying for me. So yeah, Tuana, you should we share your screen and get started?
Yeah, feel free to get my screen up on the screen, when you're ready, and tell me when I
It's up
should
on the
start.
screen.
All right. So I'm going to start off with explaining RAG. I'm pretty sure a lot of people already know what RAG is, but just in case, I'll give a brief introduction into what we mean by RAG. And then I'll talk about how we can combine Haystack and MongoDB Atlas to build RAG pipelines. And then I'll hand it back over to Pavel, and then we can start building. A quick introduction to myself. My name is Tuana Celik. The C actually has a Sadir at the bottom. This is all of my social media information on GitHub, etc. And I work for a company called DeepSet. So that's the logo that you're seeing on the left-hand side at the top. And I work in the team that builds Haystack, which is our open source AI framework. And I'm in the developer relations team there. So everything I'm going to be talking about and everything you're going to be seeing is actually about Haystack. All right, so let's start with what we mean by RAG. Hopefully there's something new here for at least a few of you. But the simple idea is, let's say we have a database somewhere full of some information, context, your own data. And let's imagine that this is a MongoDB Atlas. And then you have an instruction. This can be question answering. And honestly, most of the time it is question answering. I think it's probably one of the most common applications we're seeing. But that looks a bit like this. We have some sort of instruction or prompt, if you will, given the documents, answer the question. And then you have to quite literally augment that prompt to include the context that is within your document, as well as the question that's coming. And that happens as such. You have a question. Somehow you extract the most relevant data out of that database for that question, and you quite literally add that context into your instruction. So you have two main steps going on here. You have the query, which is interacting then with a retrieval step, where the retrieval step is looking into your database and saying, here are the most relevant documents out of this database. And the way that happens is, actually, first you're embedding your query. If you don't know what embedding is, think of it as representing your query as a vector, as a set of numbers, if you will. And then we can use that embedding to compare it to all of the others in the database. And then the second step is the generation step. And this is where you have a prompt now augmented with the correct context. And you have a bunch of options here. You can decide to use OpenAI. You can decide to use an open source model from Hugging Face, serve it with Ollama. You have many, many options, but you get to decide which LLM you want to use to actually produce your result answer. That brings me to Haystack. This QR code takes you to the Haystack GitHub. And Haystack is our fully open source framework built in Python. It's to create your own custom AI applications. And it provides a bunch of tools that we mainly call components, which you can build into pipelines to create your own use cases. A lot of the time, again, you see question answering. RAG is a big use case. You can change this to be summarization, question generation. You can also create pipelines that simply embeds documents into a database itself. And below, you're seeing like an example of what those pipelines might look like. The cool thing about Haystack, and we're going to actually build an example of this, pipelines can branch out. So you can have components that are decision components. A very good example is if you have a pipeline that's supposed to be deciding how to embed TXT files versus PDF files, for example. Maybe they have different types of converters. You can have this sort of like decision node that's branching out depending on the file type. But you can also have pipelines that loop, which is super useful because I'm sure a lot of you have been hearing the term agents or self-reflection, etc. This functionality basically means that your pipelines can become agentic, or they can become a service that runs until a certain condition is met. So it's super useful, and we're going to build one of those pipelines, hopefully. And if you take a close look into what building a RAG pipeline looks like, In the Haystack world specifically, it's the following. You have first the query, and then we have a component of type embedder. So we're going to use an embedder. Again, you can decide what kind of model you're using to create the embedding. This is going to create the query embedding. That query embedding is then used by an embedding retriever that retrieves the documents. The documents are provided to what we in the Haystack world call the prompt builder. This is a really cool component because it's very flexible, but you can provide it a prompt template and it can make that prompt template basically come to life and then provide the whole prompt to a component that we call the generator. I'm not going to go into the construction of these pipelines because I think, Pavel, you can start sharing your screen in a bit and we can actually start building them. But a few things for everyone to know about is how you install Haystack and the MongoDB integration. And we have two components for MongoDB, the document store and the embedding retriever that is able to retrieve embeddings from a MongoDB Atlas document store. Another thing I want to point out, you'll see this a lot in Haystack. We use Ginger for templating, which is pretty neat because that means you can have these for loops. As you can see here, we're looping through documents and quite literally adding doc.content for every document that's retrieved. And then we use this in Prompt Builder, which makes this template basically a component in itself. And we also have generators. In this case, we're going to be using the following model. And with that, Pavel, let me know when you're sharing your screen and I'll switch back over.
Yeah, so I'm gonna share my screen in a second. Just want to highlight that we're going to be using a already published notebook that we just published, I think, a few weeks ago. And today we're going to even enhance it. So that's what gets me excited. Is like when we are taking some basics that we built together and we're making something great out of it. And obviously, if anyone has ideas during the live stream, please post this. Maybe we'll make your dreams come true. All right. I'm going to share my screen. And I'm sharing the entire screen because I'm going to try and squeeze in some live coding of a real web application using Streamlit. I always like to do that, but we'll see if we get there. Hopefully we will. Okay, so I'm going to start with just showing the Gen AI showcase repository. Here we have all our notebooks for the different frameworks that we're working with, and one of them is Haystack, and this specific notebook is called Haystack MongoDB Cooking Advisor pipeline, and I already opened it in Collab and done a bunch of the initial steps. I'm going to go through them quickly. But the main initial step is having your cluster, right? So we have our MongoDB cluster. And in this cluster, we prepared that collection already. So I'm just gonna load. There's a bunch of other collections, but the main collection that interests us is the one on the AI shop database. I don't know why I call it AI shop. Maybe because it has like products in it, but we're gonna treat it as AI shop. And the other collection, I called it test collection. Maybe that was from a documentation or something. So, just disregard my naming conventions here. It can be anything you want, basically, as long as you follow the main configurations. The most important thing around this collection is that it has a vector index, right? So I have a lot of vector indexes, but if we search for this test collection, AI shop test collection, we have a vector index on the embedding field. I can edit it, so just we can see the configuration. So it's called vector index, and it's on the embedding field within the documents, and we're going to see that in a minute, what the documents look like.
Mm-hmm.
We're using OpenAI for this notebook, so the number of dimensions is 1,556. We're using constant similarity because we're gonna be embedding small text paragraphs. And obviously the type is vector. So that's the main configuration we have on the MongoDB side that we've prepared up front. And now we can go and move on, to the notebook, right? So initially I've installed all the relevant components like Haystack AI and MongoDB Atlas Haystack. I've also installed data sets just because one of the data set exists on Hugging Face, so I can use it, but eventually I ended up just pasting it within the notebook. Yeah, I'm importing some general libraries like OS and getPass, mainly to get the connection string from MongoDB, for example, from the user. So I already inputted that. My OpenAI key that I got from OpenAI, I also placed that in OpenAI. And then I moved on to creating the vector search, right? So we already done it, right? We create the vector search on the MongoDB Atlas cluster, and now we can run vector similarity queries, which is basically querying by the context.
Pavel, do you mind making your screen a bit bigger? The font a bit bigger? Yeah, thank you.
Yeah. All right. Okay. Hopefully now it's more visible. I always forget to do it because I'm on a bigger screen, and probably maybe some people are tuning in from different platforms. So it's always best to increase the font, right? So first we are loading all the libraries that we need. Yeah, right. We have a lot of libraries here, but most of them are just general things like Haystack pipeline, which orchestrates the pipeline basically, and the document, which is a class that represents a Haystack type document. Here it comes from MongoDB, but you support other databases. And the important part is we're using a document writer. I'm going to see that in a minute, how we use the document writer. We're using OpenAI generator, and we're using our prompt builders. All of those libraries is going to be forming our write and read pipelines. But we're going to start by writing our data. So initially, I just have a variable containing our data. And the data looks like the following, right? We have those product documents with title, price, description, category, and a fun emoji. Maybe we can use it in the web app. For now, the main thing is we are using the title as our embedding field, right? We're going to encode the title as our vectors. Right, so here is the data set, and it's quite long because there's a lot of products. Boom, 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 boom. Scroll down, right. And the only thing we're doing here is we are basically creating an array that loads the JSON documents into the Haystack document. We're converting them and creating an array so we can use in the writer pipeline. So I'm just going to run this. It will just initialize the document store. So MongoDB Atlas document store is the integration from Haystack to MongoDB that we have loaded, and now we can use this document store. It's obviously pointing to our database and to this test collection, and it also has the vector index name. The other fields, like the path for embedding, is the default value, so we're just leaving it as the default. Haystack has a great documentation. I went through many of the different elements in the documentation, and I really like that they have a lot of examples, which is really great for developers as they move along. So we've initiated the document store, and now we can actually write the document. So we're using this document writer component, we're passing the document store to it, and we're using a cool feature of if this data already exists in the database, just skip it, right? Just don't write a data point twice. Obviously, you need to state that because otherwise the data will be written as many times as you like. We have a document embedder, and we're using a Haystack OpenAI document embedder. And then the nice thing is, as we initialize those components, we can add them as components to our pipeline, right? So here we have initialized the pipeline, which is an empty pipeline, and we added two components. One is the document embedder, and the other one is the document writer. And Tuana showed me today a really, really cool feature, which is showing the pipelines. So after adding some components to a pipeline, I can basically run the show command, and it will draw a graph of the pipeline. So here we have two components. They are not connected yet, right? So that's why we see them side by side. Correct?
Yes.
So one component can do embeddings, and the other one can write documents to our document store, to our vector store, basically.
The other cool thing is you can also see what kind of inputs and outputs they're expecting. So the document embedder, it's creating embeddings, but it's returning all of the documents. You can see like the output of doc embedder has documents and meta. So you know that the entire document is being outputted.
Cool. Yeah, so now we're going to connect the two by using this command. I'm gonna comment out this one, index pipe connect, and I'm connecting doc embedder, and I'm taking the documents output, and this will serve as an input for the doc writer, which expects documents as an input parameter. And we'll also run this pipeline to save some time. But I want to show the pipeline after we kind of rearrange it, right? So we're gonna run this. So first, now we see that there's a flow. There's a connected flow of document embedder going to the document writer, passing the documents from the doc embedder to the doc writer, and eventually, obviously, inserting that into the MongoDB database. Since I already done it, we see that the number of written documents is 0 because it won't duplicate data. And we can go back to our collections and see what the data, what the data looks like. So here we have our embeddings that were made for this content, this document, vectorized spinach lasagna sheets. And the metadata is actually the entire document that served as the input for this embedding to happen. And we only took the title, right? So these are all the documents, and yeah, the stage of writing documents have finished successfully. And by the way, because the index is already defined, those vectors will already be ingested into the index automatically. Now we're moving to the interesting part, right? To build the RAG pipeline. So as Tuana mentioned before, the RAG pipeline has a prompt. And in this prompt, we're saying you are a chef assistant allowed to use the following context and only the following context documents and only those. We provide the documents. Yeah, I know we have those silly characters.
Yeah.
We'll just remove them. And here is when the fun begins. So first, every query that arrives should be embedded, right? We need to embed it into an array in order to do the contextual search. So initially, we are using a MongoDB Atlas embedding retriever together with the text embedder, right? And the text embedder we're using is OpenAI Text Embedder. This is our embedding provider. And for the retriever, we are passing the document store, the same document store we used when we wrote the data. We are retrieving 50 results. So top K is the top near neighbors, which is 50. And we're giving this component a name, right? It's going to be the retriever. This is the thing that goes into the database and queries it. The next stop is the prompt builder. Obviously, our prompt needs to have the prompt template. And as for now, it only stored as a template. The variables that we see here will only be populated when we actually run the pipeline. Finally, we need something called an LLM, right? So we're using OpenAI, and the module that we're using is GPT-4o, which is great and it's very capable. And we're calling this one the LLM. And now what's left, and this is what is so cool about this framework, is just to connect the dots, right? So anything that the text embedder that embedding produce should be passed as a query embedding to the retriever. And then the retriever passes its documents to the prompt builder at document. And then just the prompt builder goes to our OpenAI generator, which is the LLM, right? So hopefully all of this makes sense. And I'm gonna do the same here, and I'm gonna present the pipeline. So we're gonna run this thing. And as we see any text that's going to go into the pipeline, we're going to go through the text embedder, and then the embedding is going to go to the retriever, right? The retriever retrieves documents from the document store, pass it to the prompt builder. Listing. And the prompt builder passes it to the LLM. And this is how we get the reply from the LLM. Cool.
I can also point out there that if you look at the prompt builder box in the graph, you'll also see the remaining additions that it's still expecting. So if you look at the prompt builder box in the graph, you'll notice that there's query in there.
Mm-hmm.
So it's still waiting for query. So you know you have to provide query somehow. It's got documents, but it doesn't have query yet.
Mm-hmm. Yeah. And the query only comes when we are actually running the pipeline, which is the kind of last phase for this demonstration. So I'm asking, how can I cook a lasagna? And hopefully the vector store will retrieve anything that is related to lasagna and rank it higher, because the meaning for those ingredients for lasagna makes sense. And then we hope our LLM will produce a nice response. So I'm gonna run this operation. Obviously, we're not streaming the data, so we're waiting for the LLM to produce the full response for us. But this one line runs the entire RAG pipeline. And cool, we get a response. To cook a lasagna, you need to layer a variety of ingredients, and then there's the ingredients, the directions, preheat the oven. Yeah, looking pretty decent. I don't know if GPT-4 is Italian, but hopefully
GPT-4 is Italian. That would be cool.
Right.
You're also, by the way, getting lots of comments saying launch a hackathon. I'm just putting that out there. Maybe we should have a Mongo and Haystack hackathon.
Okay. Yeah, launch a hackathon. All right. I see it's coming from one person, so if it's going to be a hackathon, and
we'll have one attendee for sure.
All right,
All right.
cool. So I'm gonna stop sharing my screen after this nice code demonstration, and we can move to the really interesting parts that Tuana was working on.
All right. Feel free to share my screen once you see there should be some empty code cells in a collab.
Yay.
Yeah?
Yep.
All right. So I basically took over from this point on from Pavel, and the idea was to start showing you how you can customize the behavior of these RAG pipelines.
Before you start, we have one question from the
Yes,
chat.
go for it.
Yeah, did you guys use sparse or dense retrieval?
We use dense retrieval. Let me actually go back up. So the embedder that Pavel used, the OpenAI document embedder, by default, the model that it's using is actually this model, text embedding ADA 002. So we did dense retrieval. You could also use keyword retrieval, and you can just have like a BM25 retriever here instead, in which case you don't need to use an embedder. But yes, we did dense retrieval.
Okay, cool. Thanks, Don.
I'm also going to point out, actually, good thing that this question came now, because I did something slightly differently to you, Pavel, when I was populating my own MongoDB atlas. I was looking at all of the data you had, and it had these like titles and descriptions and prices. And there's also a way you can tell the document embedder what fields to also include in the embedding. And I thought maybe the description is pretty useful, especially if I'm asking for like recipes that might also be referenced in the description. So that's the only thing I did differently to you. I've also embedded description as well as title. Because yeah, you have meta fields to embed as an option.
Nice. We have a follow-up question if you want to take it now or later on.
Shoot, and let's see if I can answer it now.
Yeah. So quick follow-up. Does the computing speed ever become an issue when you use dense? I tried BM25, which was faster.
Yeah, of course, because when you're doing embedding retrieval, there's actually two steps. You are initially embedding the query itself with the same model. That's going to take time. But actually, the most compute isn't happening in a query time. The text that you're embedding at the end of the day is a query, and it's usually pretty short. And especially if you're using OpenAI, you've got good connectivity, that's going to be quite negligible amount of time. But what does take time is actually populating your database with embeddings, if that makes sense, because you probably, I mean, we're lucky here. We have very small documents. Maybe you have longer documents. Maybe you have lots of them. But the good news is that step usually happens once at the beginning. And then you saw what Pavel did. He said duplicate policy skip, which means that if there's new data, you're not also recalculating the embeddings for your entire database. It's just for the incoming one new document. Yeah, I think that's the best answer I can give at this point. All right, shall I customize this pipeline?
Yes.
All right. So the idea we had was, you've seen a RAG pipeline that's basically answering a question, and usually, ideally, we're just asking for a recipe, and we're getting a recipe based on the ingredients we have in our database. But the one thing that, hopefully my database is still up, let's actually check that. Let's check that I can actually inspect, hopefully. Okay. So as you can see, I've filtered the documents with no filter. So I've got all of them, and I'm just inspecting the first document in my MongoDB document store. And as you can see here, the metadata also includes something called price. And this is also a part of the document object that I have, basically. So the idea was whether we can change the behavior of our RAG pipeline to indicate the cost of cooking such a meal. So imagine that Pavel's AI shop database is like your local supermarket with all of the ingredients, descriptions, and the prices. And hopefully you want to get a recipe and know exactly how much you're going to be spending on creating such recipe. So I changed up the instruction as follows. Basically, it starts with you're a recipe builder assistant. Below you have a list of ingredients followed by its price for each ingredient. Based on the requested food, provide a step-by-step recipe followed by an itemized and total shopping list and cost. I've also gone a bit, you can definitely play around with this. I don't think it has to be this verbose, but I've also given it like an indication as to how I want the output to look like. But this is where things start to change. And let me copy over this for loop I created. So as you can see here, we have every document has content, which is what Pavel was already adding to the for loop. But we also have price. So what I'm saying is ingredient is doc.content and price is doc meta price, because we have price in meta. And that's when I end the for loop. And then finally, I'm also going to copy paste this because I'm probably going to have a lot of typos if I type myself. And then this is simply the instruction I provide. So this is my new prompt template. It's still expecting the same things. It's expecting query from somewhere in the pipeline, and it's expecting documents from somewhere in the pipeline. And ideally, documents is coming from the retriever and query is coming from the user. And then the next thing I do is I create, like first I add my components to the pipeline. LLM. Okay, and yeah, you can choose to have instance here or not. You can also just have name first and then the instance. The choice is yours, basically. And I'm calling my pipeline RAG pipeline with prices very creatively. And I'm keeping everything else the same. Top K is 50. You can also change top K at runtime. I can also show you that later if you like. And then I'm connecting these components to each other. Let's see if I've got everything right. Hopefully I do. Yes. So if you run this in a Colab or a Python notebook of any sort, you'll also get this kind of output, which is a good step to validate that you've done the correct connections. If you also make a mistake with the connections, you'll get, I can actually show you what happens in that case. I'll get an error, hopefully. Yeah, this is a pretty useful error because it's basically telling me that it cannot connect text embedder with retriever because there's more than one connection available. It's telling me that there's an embedding and meta output, and there's a list of float and dict here. And then there are all of these inputs that the retriever can expect, and it's saying, I just don't know which to connect to which. So that's why it's basically asking you to be a bit more specific, which output should go into which input. And that's the thing about Haystack. I think it's quite verbose, but it means that you can build pretty custom interactions. Okay, so let's also do this, Pavel, since you like it.
I like velocity.
Sorry?
No, I've learned through time that there's no that the more specific you're doing the prompt, the better you'll get the result. So don't spare words.
Yeah. All right. So let's try to run this. So let's have the same question, and remember, in an ideal world, we want this to be providing us some indication of price. If it doesn't, I will be very sad and will have to correct my pipeline somehow. So I'm going to be running this and assigning the results to something called results. And a good way to know what to print out is to look at the final component in the graph. So I know that the last thing is going to be LLM replies, that's a list. I need the zeros, basically, at this point. We only have one question. The other thing you can do here, which I know has been quite useful to some, if you need to inspect what happened for example, what kind of prompt was built, you could also say, include outputs from and provide the name of one of your other components. And then the result will also include that. But I don't need that right now, so I'll take it away. All right, let's try. I really hope we get the prices. I'll be so sad if we don't. It's also taking a while.
Yeah, because we're waiting for the entire response, and now you got the response longer. So
yeah.
All right.
You can maybe even go into your database and validate this, because it's told me I need to use the eggplant. Okay, it's actually decided we're having vegetarian lasagna. Okay, fine. And it's provided me with the price from my database. And then it's also hopefully provided me the total cost. Now, we're not checking. There's so many things you can improve in this pipeline. For example, you can even have a separate component or even a tool if you're going to build like a function calling pipeline, which is possible, to actually check that the mathematics is correct here. Like, there's so much that you can improve. But this is just to show, by simply playing around with what you have available in your retrieved data and adding that into your augmented pipeline, you can play around with the behavior pretty significantly. Okay, shall I go to the next one? Are there any questions that I can answer already here?
There's one question from before we started the pricing enhancement. Are we using embedding functions here?
Embedding functions.
Yeah, embedding function. So we're using OpenAI module to embed the data, and the module is the ADA002. So hopefully that answers the question.
It might be about similarity functions here.
Okay.
So I think it's cosine that we're using.
Yeah, it's cosine because we're using small texts.
Okay, so the next pipeline, I want to preface this by saying this pipeline that I'm going to show can definitely be made better. But it comes with a few cool bits and bobs about Haystack, which is probably quite useful. So you saw a bunch of components already. You saw the OpenAI generator, the OpenAI text embedder, document embedder. You can obviously replace all of those with different model providers like Cohere generators and text embedders and document embedders. You saw document writer, for example. But more often than not, Haystack actually doesn't have the components you need, but that's not the point of the framework, if you ask me anyway. The framework is meant to provide you with a simple interface and abstractions for you to be able to build your own if needed. So what we're going to do here is we're going to create our very own Haystack component that does something very simple and specific, which you can definitely change. And we're going to create, in an ideal world, a pipeline that's able to self-reflect. And what it's going to reflect on is this the cheapest and most efficient way I can do this recipe? Or is there a set of ingredients that could make this cheaper? And is there a way that I can make this more efficient to cook? So I'm going to start building that. Pavel, feel free to interrupt and ask questions if there are any while I do this. I'm going to be using, we very much use this package called Colorama because it allows you to print out stuff in different colors. And especially if you have a self-reflecting pipeline or loops, you're able to see the different steps of the loops in red and then the final result in green, which is nice. So if you don't want it, you don't have to install this. But let's start. So I'm going to be creating a Haystack component. And for something to be a Haystack component, it needs to use this component decorator, and it has to be a class. So I'm creating this component called the recipe checker. And you also need to have a run method. So we're going to have this run method that expects replies. And maybe this already looks familiar to you because we already know that def run. You already know that an LLM or a generator outputs replies as a list of strings. And from here on out, let's build it. So for something to be a component in Haystack, you need it to be a class. You need it to have the component decorator. It needs to have a run method. And when I have this run method, basically replies is what we expect as input to the recipe checker. And it has to return a dictionary. So in this case, I'm going to have an if-else statement, which is going to be incredibly simple inside this run method. And simply what it's checking here, and this is where I'm saying that this could be made a lot better, if you ask me. If you do make it better, please let me know. And what's going on is it's checking in the replies if there's something that says done, if replies has done in it, which is terrible, by the way, because you can have done in any part of the recipe. Maybe we can change this. Maybe we can have it say done, like in caps. Let's do that. It's going to return the recipe. Let's correct that. And if there is no done, it's going to return something called recipe to check. And this is going to basically mean that the LLM has decided that it could do better. So that it hasn't said I'm done. So we have to output the reply as recipes to check. And this is where I'm using Colorama. And we're going to know that the LLM is still thinking about how to make it more efficient. Now, the final thing you need to have to make this a Haystack component is to have a decorator around the run method itself too. And this is basically telling the rest of the pipeline what kind of connections are available. And it's basically saying I'm outputting something called recipe to check and recipe. They're of type string. So the pipeline knows that if anything connects to this, it has to be expecting strings. And that's it. So now I have a recipe checker. And hopefully I have not done anything wrong here. Maybe we could try run this and see what happens. And let's say replies. And we're mocking an LLM response now, my recipe. Hopefully, yeah, that should work. And you can see, because there's done here, it says, here's your recipe. If there was not done here, it would, yeah, you can see it's printing out this and it's saying there's a recipe to check. Again, this is pretty hacky. But now let's see how we can actually use this. So this is where things start to get slightly Haystack specific and complicated. But let's start with the same prompt you saw before. I'm giving up on indenting this correctly. So all of this is the same as before. But as you may recall, Haystack uses Ginger, which means I can have these if blocks. And I'm saying if there are recipes to check, and I'm adding some very simple instructions. Is this the most efficient and cheap way to do this recipe? If yes, say, now I need to change this, done, and return the recipes. And then let's also ask for the recipe at the end. And that's it. So next, I'm going to go ahead and add all of these components to the pipeline again. There's nothing new here, apart from the fact that I am adding my recipe checker and I'm calling it checker. And next, I'm going to go one by one because it can get kind of complex. So we have the text embedder going to the retriever again, and then the retrieved documents are going into the prompt builder again. And then the prompt builder is sending the query off to the LLM, but the LLM is then sending off the response to the checker, and then the checker is going to be sending the recipes to check to recipe to check in prompt builder if it's there. And I really hope I got that right. And then we can also show this. I think when you show it, it makes a lot more sense. Okay,
Yeah.
Here you see what's going on. We have the prompt builder, then the LLM creates a recipe, and then in replies, and then the checker.
I like the dotted
back. Yeah.
I like the dotted line that it shows you exactly what will happen if we're in this loop.
Yeah. So maybe we're going to have recipes to check, or we're going to have a recipe. And let's see if we can actually get the lasagna recipe to be a bit cheaper. Last time I did this and I showed Pavel, it was just like 50 cents.
Yeah, the vegan lasagna was pretty pricey.
Yeah, let's see. Oh, another thing I didn't mention, which let me actually scroll up while this is going, is when you create these types of pipelines that have loops in it, you can also have some guardrails. So we're just basically saying if you loop 5 times, fail. And this is just making sure that we're not querying OpenAI continuously.
Can we say if you're looping 5 times and you didn't find a recipe, like just output the last one?
You could do that, I think, but we succeeded. $26 this time. So you see that it's tried twice.
That's the cheapest one in all of our testing.
Yeah, there you go. Yeah.
Nice.
And there we have it.
Very cool.
Are there any questions so far? Because if not, I'm going to skip to a quick intro into how we deploy these.
Yeah. So there's one question: are there any plans for Haystack to provide support for other languages than Python? I don't know.
Oh, we get this question a lot. It's not in the immediate, foreseeable future, but we get this question a lot. So never say never. But right now we are focusing on the Python.
Yeah, that was a question about Go and Rust, but I believe like Node.js would probably come earlier than one of those languages.
Let's see.
Let's see. All right. Would you consider the agentic RAG within? Would you consider this agentic RAG with a checker and repeat loop? Would you consider this agentic RAG with then?
I guess the question is, would you consider this agentic RAG?
Okay. Yes.
I think it's a form of agentic RAG. Definitely. Yeah. You can also, I think we're not doing it in this live coding session, but there's another way that to me is a bit even more agentic RAG, is you can, maybe some of you already tried this. So a lot of model providers now have function calling or tool functionality, if you will. You can provide full Haystack pipelines, so your RAG pipeline, if you like, as a tool to a generator, which is pretty neat. And then you can have basically agentic RAG that has memory and have a chat agent that runs your RAG pipeline if it needs to. If not, it might run a different tool.
Yeah. What is the benefit of using AI for checking itself versus regular unit testing human feedback? And are there ways to get the latter cheap?
I can answer that question too, if you like.
Mm-hmm.
I think this is still very much in research, all of this right now, but there's definitely quite a lot of research papers who have found that asking an LLM to self-reflect is just a good way to make it provide this better answers to the original answer that it gave. This is just an example, self-reflection. However, there is another, and we have this tutorial on the Haystack website if you're interested. Self-reflection is just one use case of creating these loops. It's a nice and easy thing to show people on how to implement these loops. And in this case, it seems to have worked. But you can also have loops that are a lot more similar to human validation. For example, we have a tutorial out there that is able to have a custom component that is an output validator, which validates whether your structured output abides by the Pydantic model you want to use, for example. There's no LLM in this. It's not actually even self-reflection. The only thing provided back to the loop is, let's say your validator had errors. So Pydantic told you this is not the correct schema for the structured output that I want. And the only thing that the LLM is provided later is the error message and the invalid reply, the invalid output that it generated. And then it simply uses the error message to correct itself. That's a lot more like human in the loop. So yeah, there are definitely more use cases. And you're right, we might find that there are probably a lot more efficient ways to do this. Yeah.
All right. We want to do a quick JSON format output thingy before we move quickly to the hosting part?
Yeah, let me just quickly walk through what we mean by serialization. So quickly, Haystack pipelines, all of these pipelines you've been seeing above, like the reflecting RAG pipeline, etc. What we mean by serialization is you can represent that in, for example, YAML, which is a format that's really easy to send down the wire if you need. You also have some instructions there on how to deploy these pipelines, but simply you just call, in this case, I've called dumps. So I'm going to dump this out as a YAML string. And you can see that the RAG pipeline that Pavel created is represented as this YAML config file. And then you can also do the same, but instead of like printing it out, you can write it out to a file, which is super useful because you can then use a tool that we have called Hayhooks to deploy that RAG pipeline. And then you can go to this, it deploys it locally by default, and you can go and interact with your HTTP endpoints, your pipeline as HTTP endpoints. And that's it.
Great. One last thingy that I wanted to kind of bring up before we wrap this up is, it's really great that tools like Haystack, MongoDB, and OpenAI can produce those really insightful text responses based on the context within our database, and obviously using embeddings and the whole RAG method. It's just that when we're building web applications, we usually have trouble working with something like this sparse, text output. So a lot of the LLMs offer the capability of going to our generator, to our OpenAI generator, and adding a feature adding a flag to actually response within a JSON format. And then we can use our prompt to describe what kind of JSON are we expecting back. So I went to the Haystack documentation, and I've noticed that the OpenAI generator receives any OpenAI reference kind of APIs and flags using this just generation keywords, right? So I'm going to use this nice type JSON object feature or response format to get a JSON back. So I'm going to add this one to the pipeline that we saw earlier that I was running. And we gonna just provide the the response format. So hopefully I can type in the word response format correctly and pass in this type of JSON object. And one important thing is that we would want to basically edit our prompt a little bit. So I've prepared that up front. It is a bit long, but I've hopefully I'm gonna go through it. Right. So it starts the same way, but here we're saying use the context documents and only those in JSON format. Let's say and include only relevant recipe data. It must have all the markdown under markdown text field, ingredients field, and price mean max. So hopefully this thing can produce this type of JSON document, right? So I'm just gonna run this to prepare the pipeline. Cool. So now we can see that we are having still the same type of output from the image, but here we're going to print the basically. I think we can print the same LLM replies path. So I'm going to ask the same question. I'm going to run this pipeline. Hopefully, it won't error out as Tuana says every time she runs a pipeline. And we're going to see what type of response we are getting back.
Not gonna lie, I've never tried the JSON output flag.
Oh yeah, yeah. It's pretty nice. It outputs the same format, but in a JSON format. So now when I code, it's really easy for me to get to all the different parts. So we see that for some of those ingredients, we actually found a few options. So they immediately uses the document model to better explain the type of documents that we found. And it says that, it's basically that the pricing moves between 20 and 40. I think it didn't really calculate, but it made an assumption based on like the amount of ingredients. So yes, I don't know if we can count on this field that is particularly precise. I think the self-reflection pipeline is obviously much more precise than this assumption. But now we can use this pipeline easily in our web applications. So hopefully we can have maybe a follow-up at some point and actually build a whole web application using the JSON format outputs.
Nice.
Right. Yeah. So hopefully that was fun and insightful to everyone. We're just hit the top of the hour. So obviously come and connect with us. Join the MongoDB community. Register to Atlas. Go to the Haystack website. Yeah, let me share quickly the Haystack integration, right? So this is the Haystack and MongoDB tutorial on the MongoDB website. And we're also having, there's also the Haystack integration on the Haystack site. So we're having the short link. And we're going to post the pipelines that were produced here on our GenAI showcase repo later on. So right now you can see the basic pipeline that we have here that was presented in the beginning. You can play with it already. And we're gonna post shortly the entire pipeline with the agentic agent and everything. Wow, there's a lot of content. I think a lot of people
Yeah.
need to just and maybe rewatch the recording once it's up. It was a great pleasure having you, Joanna.
Thank you. I'm enjoying that someone pointed out $26 for a lasagna in 2024 is cheap. I think we accomplished.
Yeah,
I think we accomplished making a recipe cheaper at least. Nice.
yeah. So thank you for everyone that's tuned in, and hopefully people are gonna watch the recordings. And we're gonna probably do more stuff later on this year towards.
Yes, let's have a hackathon as this person suggests. But thank you
Yeah,
very much for having me. This was fun.
yeah, it was really fun. Thank you, Joanna, for sharing your knowledge and your expertise. Um, Bye, everyone.
Bye everyone. Thank you for joining.